Please write this down. Comparing theoretical and experimental probability. Today's date is going to be October 30th. Okay. So again, I do want you to answer this question. Who is your favorite superhero? And can you guess who this guy is? Or can you guess who this guy is? Alright, so please, again, write the question down and answer it. This I want you to write down because this is going to be our central idea for probability. Instead of luck, mathematicians use probability. So again, the same thing that we did the last time. Let's see if I can find an example. Not that one. I will show you one in class because we did this. So in probability so far, you can talk about simple events. You can give me an example and a definition. You can talk about compound events. And then you can talk about independent. Right? We talked about that on Friday. And you can talk about dependent. And again, I would like for you to expand on these, write the definitions, and give me examples of each. You can talk about replacement, without replacement, okay. Let's see what else you can talk about. Outcomes, sample space, all these words, right? Tree diagram, right? Tree diagram, once that goes like this, right? That's an example, so you can give me examples of those. What we're going to talk about today, theoretical probability. We're going to talk about experimental probability today. We can use the word spinner, right? You can show me what an example with a spinner or a number cube. Right, that's a number cube right here. You can talk about unlikely, likely, as likely as not, certain, impossible. Right, all these are examples of what you can put on this around the central idea. Instead of luck, mathematicians use probability. Yeah, so this is a good start for you to have. So at the end of the unit, when we do the central idea, you have a lot of these words. And all you got to do right now is expand and give me examples and definitions. Okay, so that's a good start. Next, so let's talk about this. What's the probability of a coin landing on tails? So the probability of tails, right, on the coin. I should have taken a picture out. So coin. Sorry. coin, this is heads, and penny tail. Where do we have tail? Yes, this is tail right here. So on a coin, we have this is heads, this is tails. So the probability of landing on tails is 1 over 2, right? Because there's 1 tails out of 2 possible outcomes. So how many tails would you expect on the next 300 tosses? So if you were to throw this coin in the air 300 times, how many times would you expect it to come in tails? Well, we can use a probability, right? So we can use this. Right? We can go 1/2 times 300, and that'd be 150. So if you were to do an experiment and throw the coin 300 times, you would expect that 150 will land on tails. Would that happen? Maybe, but that's your expectation. So on a die, now this one is a die. Okay. What's the probability of what's the probability of rolling a 1 or a 3 on a die? So probability of 1 or 3. So remember, this is a plus, right? So we have the numbers 1, 1, 2, 3, 4, 5, and 6, right? 1, 2, 3, 4, 5, and 6. And we want a 1 or a 3. So a 1 or a 3. So that would be 2 out of 6. And this can be simplified to 1/3. Yeah? So now it's asking you how many times would you expect a die to roll a 1 or a 3 on the next 80 rolls. So if you were to do this 80 times, right, how many times out of 80 would you expect it to land on 1 or 3? Well, we can use the information we just found here. Right? We know the probability of 1 or 3 is 1/3, so we can go 1/3 and multiply it, right, times 80. And that's going to be, Alexa, what's 80 divided by 3?
80 divided by 3 is approximately 26.6667.
Right, so it's 26.66666 forever and ever, which we're going to use that. But you can't throw a die 26.6 times, right? So this becomes 27. 27 times, you would expect the die to roll a 1 or a 3. Okay, so that's what we've done, right? Now, look at this question. What's the probability that your yellow bus will be late tomorrow? So how are we going to do this problem? Are we going to look at the bus and just infer based on how the bus looks if it's going to be late tomorrow? How do we find out? How do we calculate the probability of that happening? Well, the only way to calculate the probability of your bus being late tomorrow is to look at the bus's history, right? In the past 10 days, the past 20 days, how many times was it late? Well, I have that with me. So in the last 10 days, the bus was on time 8 times, and it was late 2. So we can use this information and calculate the probability of him being late tomorrow. The probability of late tomorrow is going to be 2, right here, out of how many? 10, which is simplified to 1/5. But this, right, I needed to use the bus's history. I need to use the actual bus coming to your bus stop the past 10 days, right? Record that, and then determine the probability for tomorrow. So there was an actual experiment that happened, right? An actual action that happened. Whereas this, right, when I asked you what's the probability of 1 or 3, we didn't roll the die, right? We didn't roll the number cube. We just looked at it, and based on the information that we had, that we saw in front of us, we determined that it was 1/3. Same thing here. when I asked you for the probability of tails, well, we looked at the coin. We know that it has two sides, right? Two different outcomes, and one of them is tails. And that's how we got 1 out of 2. And then we use that information to figure out, right, to predict what's going to happen in the future. Okay. Now, the only difference here is that to find the probability of the bus being late tomorrow, I actually had to see an action being performed. And that action was the bus coming to your bus stop for the past 10 days. Okay. So we're going to do this in class, but I do want you to write it down. So by the time I get together with you guys, we all have the same information. So Sam tosses a coin 20 times. So we're going to toss a coin as a class 20 times. And we're going to record how many tails, how many heads comes out. Okay. This is called an experiment. We're actually going to do an experiment. We're going to throw the coin in the air 20 times and record the outcomes. Okay. And the probability that we are going to get or determine from that is going to be called an experimental probability. Okay. So because if I asked you right now, what's the probability of getting heads on a coin, it'd be 1 out of 2. What's the probability of getting tails on a coin? It'd be 1 out of 2. And that's based on us examining the coin. We didn't throw the coin in the air, right? So that's called the theoretical probability. Okay, so we're going to do this. So we're going to do this in the class. And we're going to use the results of our little experiment, right, to determine future outcomes. And that is going to be called experimental probability. Okay. Let's look at this one. Maybe this helps you a little bit more. The table shows the result of a spinner experiment. Find experimental probability. So now there was a spinner. Okay, so I should change this. I should actually change this is red. And these are wrong. Well, you know what? I'm going to put number 1, number 2. No, sorry. 1 second. So let me take these guys out. They're wrong. So this one should be red. Now put red. This one should be blue. So I want you to copy this table. It should be green. And the last one should be orange. Okay? So we're going to determine the theoretical and the experimental. So now for just 1 second here, let me see if I can hide this. I can. I'm going to hide this. Okay. So if I asked you right now, what's the probability of the spinner landing on red? You're going to say, well, there's 1 red. The probability of landing on red is 1 out of 4. What's the probability of landing on blue? Well, same thing. How many blues do you see? There's 1 out of 4. Not green. So not green is red, orange, and blue, right? So you don't want green. So we have 3/4. And then orange or red, remember we're going to put a plus sign over here. So orange, there's 1 orange. How many reds? There's 1 red. So this would be 2 out of 4, which simplifies to a half. That's the theoretical, right? We're looking at the spinner and we're using the information that we see to calculate these probabilities. Now, the experimental probabilities, so this is a little bit different. So imagine, or just for a second, that we spun this, right, the spinner. The red, we did this 50 times, right, so there's a total of 50. And imagine that I spun this and I got 6 red, 11 blue, 19 green, and 14 orange. Now, I asked you, what's the experimental? In the experiment that we just did, right? We actually did an experiment in the actions that were performed 50 times, how many times did we get a red? Well, red was 6 times out of 50. Blue was 11 times out of 50. Not green would be the orange. Not green, not green, not green. So that would be 31 out of 50. And then orange or red. Orange is 14. Red is 6. That would be 20 out of 50. That's the difference between theoretical and experimental. Okay, so one is based on an experiment that actually happened. And this one, it's not based on an experiment that happened. Okay, so that's the difference between theoretical and experimental. All right, so we're going to do a dice experiment. I don't think we're going to have time today, but tomorrow you're going to come. You get this. So let me explain it to you. You're going to get this handout, and you're going to roll a die, a number cube, 30 times. Okay, and you're going to record the frequency. So if the number 1 comes out, you write 1, and number 1 comes out again, you write another 1. If number 2 comes out, number 5 comes out, number 3 comes out, and you're going to do this 30 times. Just notice that when you do these tally marks, after every 4, you cross it out, and that becomes 5. Okay, so you're going to use that. And then you're going to answer the questions at the bottom. All right, which I will go over with you guys, but I'll go over it right now. So again, on the number cube, right? Here's a number cube. Right? What's the probability of rolling a 2? Well, 1, 2, 3, 4, 5, 6. The probability of landing a 2. There's only 1 2, so it's 1 out of 6. What's the probability of rolling a 5? 1 out of 6. What's the probability of 2 or a 3? That would be 2 out of 6, or 1/3. Greater than 4 would be 5 and 6, so that's 2 6, or 1/3. 5 or less would be 5, 4, 3, 2, 1, 5 out of 6. So again, all these, right? All these probabilities are calculated, right? We're getting all these probabilities by the information provided to us on the die. We're not doing an experiment, right? Well, after you finish the experiment tomorrow, right, and you have this table completed, you're going to use that information to complete this side. Okay, and then at the bottom you're going to answer a few questions. Okay, so that's it for now.